Welcome to this explainer. Listen, if you're an electronics and communications engineering student, you are in exactly the right place today. We're going to reframe your degree for what it truly is, the ultimate superpower for our digitized future. The whole world is pivoting toward deep tech integration, and your specific skill set, it's becoming the foundational infrastructure for literally every major innovation on the horizon.
So I want to ask you directly, especially those of you grinding away in your second, third, or fourth year of your ECE program. Are you really ready for 2030? Are you prepared for the massive, exciting shifts coming to your industry by the end of this decade? Because the landscape is changing so fast. The days of ECE just being about discrete components and traditional telephony are long gone. You're stepping into a systems-level architecture role that defines the actual boundary between the physical and digital worlds.
Okay, let's dive right into this with a number that should absolutely catch your attention: 1 trillion. The global semiconductor market, which is the absolute core of your domain, is projected to cross a mind-blowing $1 trillion by 2030. This is being driven by a massive convergence of AI, the Internet of Things, and electric vehicles. If you ever needed validation that you picked the right major, well, there it is. Your skills are the bottleneck to future progress, which means you are going to be in incredibly high demand.
Here's our roadmap for today's session. 1. The 2030 ECE landscape. 2. High-growth sectors. 3. Essential skills and coursework. And 4. Global salaries and opportunities. Let's jump in.
Section 1. The 2030 ECE landscape.
Now, what's really interesting here is how the generative AI boom has created an exponential explosion in data generation. To handle the physical reality of this AI boom, we're actually moving away from general-purpose chips and moving heavily toward application-specific semiconductors. These massive data centers need highly specialized, incredibly energy-efficient ECE architectures. Things like thermal management, low power consumption, and advanced packaging are the new frontiers, and ECE engineers are the exact people tasked with designing these systems.
Beyond AI, you'll be building out the Internet of Everything, or IoE. Think of this as a massive step up from the Internet of Things. While IoT focuses on connecting smart devices, IoE connects people, places, and data. By 2030, we're looking at a sci-fi reality where everything from your smart home appliances to city roads, waste collection, and power grids are all interconnected by ECE hardware. You'll be the ones designing the low-power edge devices that make these fully automated smart cities possible. And how does all that data travel? Through 6G. By 2030, 6G networks will start coming online, offering speeds up to 100 times faster than 5G. We're talking 1 terabit per second. And this isn't just about downloading movies faster. Zero-latency communication means true mixed reality, 3D holographic meetings, and remote robotic surgeries performed across continents without a single millisecond of lag. It's a massive leap in infrastructure, and you are the engineers who will harness those terahertz wave frequencies to actually make it happen.
Section 2. High-growth sectors.
A truly massive area of growth right now is the automotive sector. Autonomous vehicles are essentially transforming into high-performance computers on wheels. By 2030, EVs could make up 50% of all vehicle sales. And what does that mean for you? Well, power semiconductors, like silicon carbide, will account for over half the cost of these super smart software-defined cars. From advanced driver assistance systems to the centralized computing power replacing traditional car mechanics, the automotive industry is rapidly becoming a core electronics industry.
When you're looking at these high-growth sectors, you basically have two fantastic career paths to weigh. On one side, you have core electronics roles. Think VLSI chip design, FPGA, and embedded systems in product-based companies. Because semiconductor manufacturing is expanding globally right now, these specialized roles command significant salary premiums. On the flip side, many ECE grads transition into the software and IT sector. Roles like IoT developer or cybersecurity leverage your incredibly strong ECE programming foundations. Both are highly lucrative, amazing choices depending entirely on what sparks your interest.
Which brings us to Section 3, Essential Skills and Coursework.
Let's bring this futuristic vision back down to earth for a second. Your standard BE program outcomes actually map perfectly to these massive global industry demands. So, when you're in your second or third year struggling through advanced signal mathematics or complex circuit design labs, I want you to remember, this is not just busy work. This foundational problem solving is exactly what's required to fix global power consumption bottlenecks. Your rigorous coursework is building the exact framework you need to tackle these huge hardware challenges.
To be highly competitive out there, you need a specific blend of technical and soft skills. Yes, you absolutely must know your digital and analog electronics, embedded systems, and PCB design,
But you want to know the real secret weapon? Programming. Knowing Python and C alongside your hardware expertise is an absolute superpower for an ECE student. The engineers who can bridge the gap between software algorithms and physical hardware are the ones who are going to lead the industry. And of course, never underestimate team collaboration. You'll be working in global multidisciplinary teams.
So, here is your action plan. Think of this as your roadmap to becoming totally irresistible to employers. First, pay attention in your core subjects and take your lab work seriously. Second, learn programming alongside your hardware studies. Third, don't wait around. Secure those internships in your second or third year. Fourth, build your own small IoT or robotics side projects to prove you can apply what you've learned. And finally, stay focused on preparing for placements and exams. Follow these steps, and you're going to be miles ahead of the competition.
Section 4. Global Salaries and Opportunities.
Because these skills are universally needed, your degree is essentially a global golden ticket. Let's look at the top-paying international markets. Switzerland leads the pack, with an average salary of over $125,000 USD. The USA follows closely at over $111,000. And regions like Denmark, Canada, and Germany are heavily investing in tech and domestic manufacturing right now. They are actively seeking skilled engineers like you to drive their local ecosystems. Zooming in on the highest-paying specific roles, the financial return on niche skills is just tremendous. FPGA engineers, those are the folks working with field programmable gate arrays, they top the list at over $130,000 on average. Senior electrical engineers and RF engineers, who are absolutely vital for that 6G rollout we talked about, are also commanding massive premiums. Bottom line, the more specialized your knowledge is in bridging physical hardware with complex systems, the higher your value.
To sum up this explainer, I want to leave you with this thought. ECE connects the physical and digital worlds, shaping the world of tomorrow. You aren't just students memorizing circuit diagrams. You are the critical stakeholders who are going to build the global infrastructure of the next decade. From the chips powering AI to the 6G networks connecting our cities, literally none of it happens without electronics and communication engineers.
So the crucial takeaway is this. The opportunity is immense, the compensation is fantastic, and the impact you can have is literally world-changing. Are you ready to architect the programmable physical world? I hope this roadmap sends you into your next lab assignment absolutely filled with enthusiasm and a drive to learn more. Keep building, keep questioning, and I'll catch you in the next explainer.